So after studying the electromagnetic field because of point charge, line charge and either sheet charge or surface charge, we move to the next point, that is Gauss law. Prior to that, there is a concept of electric flux. We are well aware of the terminologies. Number one, electric charge Q, and then electric field E. Electric field E. So, because of this electric field E includes Q upon 4 pi epsilon r square. Right. So electric field E, because of charge, depends upon medium. Right. Permittivity is a thing coming into picture. So this is what we can say, somebody said coming into picture when I put a pause. So that indicates that in the teaching learning process, when teacher talks, the teacher's talk should be such that if it is absurd, then nobody knows what I will talk. If it is recorded and one has gone through earlier, then everybody knows exactly what I will talk. Both are the extremities. What happened today is an indicator that when I talk one sentence, the normal regular student should be able to estimate the next sentence, which may or may not be always correct. Means when I talk something now, what next I will talk, that one should be able to predict, and that prediction should, in normal case, should be correct. In some cases it may be different. Now if this epsilon is taken on the other side, so that is very obvious that epsilon taken on the other side, become epsilon E will become independent of medium. It will become independent of medium, that is Q upon 4 pi r square. So this epsilon E, listen carefully, it's not very difficult, but we will move further. The Gauss law, what you have studied in junior college days, we will refine it to a point form, and for that we will need much derivations of vector calculus, that is divergence. Then for electric potential we will need gradient, and we will be needing curl also in some other case. Curl, divergence and gradient are quite significant terms in vector calculus. So this epsilon E is named as D, and it is called as electric flux density. D is called as electric flux density, and E is electric field intensity. When we use field, but the more classical abbreviation is electric field intensity, E, and when it is multiplied by epsilon, it is electric flux density, D. Is it clear? So D is equal to, for a point charge, Q upon, means if we talk of now in Coulomb's law, Q1 Q2 upon 4 pi epsilon r square is a force. Is a force. Force experienced by unit charge is field, and field field multiplied by permittivity is flux. Is it clear? So the terms electric field intensity and electric flux density should be very much clear. Okay. Now what is Gauss law? What is Gauss law? I think Gauss law you must have studied in 11th, 12th. What it states? What is Gauss law? Electric flux over a closed surface. Electric flux over a closed surface is equal to electric charge enclosed inside the surface. Electric flux over a closed surface. Now what you are doing? Hello? Look here. Now this term is very important. Electric flux over a closed surface. And flux density and field intensity are the terms. In some cases, in normal utterance, even in some books, you may find that the density word may or may not be used. So electric flux is used, it is electric flux density D, and electric field intensity E, we use the term electric field also. So electric flux over a closed surface. Now here we need to think over it. What are you doing? What we mean by electric flux over a closed surface? So electric flux is a vector quantity. We must get acquainted to the term electric flux over a surface. Electric flux over a surface. And then a closed surface. So what we mean by over a surface? Laksha laga? Mean electric flux. If there is some electric charge, let us say that in the universe, only one point charge is existing and somehow it is fixed there. So that will create electric flux around it, right? So at every point there will be some electric flux. Is it clear? Electric flux is a scalar or vector quantity? Vector quantity. Means it is having magnitude as well as direction. Then electric flux over a surface. What it may mean now? Rather than asking what does it mean, I will ask what it may mean. Electric flux over a surface. So for that we need some surface. It may be closed, is a latter part. So flux over a surface, what is your perception about it? Laksha laga? Gauss law states that electric flux over a closed surface is equal to electric charge enclosed by that surface. So closed is a different part, but we must be well aware about the term electric flux over a surface. So how will you deal with the term? What do you understand exactly by the term? Electric flux over a surface. At every point in the universe, there will be some electric flux. A surface is what? What is surface? No, closed is a different part. Surface. What corresponds to a surface? Are you getting me? See, it means some terms we are so well acquainted with that we are unable to describe them. What do we mean by surface? What we mean by point is there, then if we are having adjoining points, then we get a line. Then when we say line, it's either a straight line or a curve. Is it clear? Means collection of uncountable infinite points. Collection of uncountable infinite points is a line. Then a curve. So a line is having one dimension. Point is dimensionless. What we will call as a curve, and there is surface. लक्षात आलं का? पॉइंट डायमेन्शन नसलेली एंटिटी म्हणजे पॉइंट. एकच डायमेन्शन असलेली एंटिटी म्हणजे लाईन, ज्याला फक्त लांबी आहे, रुंदी अथवा जाडी नाही. मग कर्व कसा तुम्ही डिफाइन कराल? कर्व, हाऊ विल डिफाइन अ कर्व? कर्व लाईनला पण जाडी नाही, रुंदी नाही, आणि लांबी जे आपण एक दोरा कर्व एक्सप्लेन करत असेल तर दोरा घ्यायचा, लाईन वर ठेवायचा. पण दोऱ्याला अर्थात हे तो डायमीटर येतो, पण तो निग्लेक्ट करायचा आणि तो असा कसाही फिरवला त्या प्लेन मध्ये, तो कर्व झाला. सो लाईक दॅट मीन्स when we say line, it's a, if we don't specify it, it's a straight line, but otherwise it is curve also. What is the area of the line? What is area of a line? What is area of a line? Area of a line. What is length of a line? Length of a line is defined. Listen now very carefully. We are having point. Point is having zero, no dimensionless. Infinitesimal width, infinitesimal length, infinitesimal width, length and depth. Collection of uncountable infinite points. Collection of, listen very, it's very meaningful term. Collection of uncountable infinite times, uncountable infinite points in a particular manner lead to a line. When it leads to a line, it gets length. It gets length. We have infinite line. We are having infinite line. Its width and depth are zero. What is area of infinite line? Area is zero. Infinitesimal into infinite can be anything. It's a very important point to be noted down. Infinitesimal into infinite can be anything, including infinitesimal, finite and infinite. कळलं काय बोलते? Infinitesimal, which we defined instead of zero, because zero leads to something on our mental plane which is embossed. आता टॅटूची दुकान आले बघा मागे येतात, किंवा पूर्वी गोंधणे माझा कन्सेप्ट होता. म्हणजे झिरो हे लहानपणी शिकलं असल्यामुळं आपल्या मनपटलावर ते एका प्रकारे गोंधळ गेलेलं आहे, ते पुसता येत नाही. Therefore, we introduce a new term, infinitesimal. Infinitesimal and infinite. Infinitesimal into infinite can be what? It can be anything. Infinitesimal into infinite is indeterminate. It can be finite, it can be infinitesimal, it can be infinite. So how? What is line segment? What is line segment? Collection of uncountable infinite points its length is finite. What is infinite line? Collection of again uncountable infinite points. Its length is infinite. What is area of a segment? Area is not anything. Area is length into width. What is length of a segment? Finite. Width infinitesimal. So that finite into infinitesimal is infinitesimal or zero, you can instantly answer. But if you take an infinite line, what does it say? Length? Infinite. What is the width? Infinitesimal. What is area? No, what is area of a line? Area of a line is infinitesimal, or in conventional term, zero. So that is line. So line or curve, line including curve is collection of infinite, uncountably infinite points in such a manner that they constitute length, which is either finite or infinite, but do not constitute either area or volume. अच्छा लगा? Infinite in a 3D Euclidean space, line is collection of such infinite points so that it constitutes either finite or infinite length, but does not constitute either area or volume. Then what is surface? How do you define surface? Let us see, at least, Lakshal na? What is line? Now what is surface? What is surface? Collection of infinite curves or infinite lines, you can say, or but there is no need to use that terminology. You can construct directly from point also. How? It is collection of uncountably infinite points in such a manner, and it is now line is line. When we talk of a line, straight line, obviously it is in single. Means it's always, a straight line is always coplanar. A straight line is always coplanar. A straight line is always coplanar and is coplanar in a straight line is always coplanar and coplanar in infinite planes which pass, means a straight line resides in infinite planes, this plane, and all. is always coplanar. A straight line is always in a single plane, and such single planes in which it claims it exists are infinite. What about curve? Curve is always coplanar. Curved line. Curved line. It may or may not. The moment at which it is curved line, it can be in only one plane, not multiple planes. Straight line, it is in this plane also, this plane also. Is it right? This plane also. When we talk of a curve, the moment at which we talk of a curve, it can be at most in one single plane, or मैं दोरा घेतला, दोरा जमिनीवर ठेवला सरळ रेषेत, स्ट्रेट लाईन. दोरा जसा ठेवलाय तसा जमिनीवरच ठेवला, पण स्ट्रेट पासून वळवला, कर्व. पण तो काही पार्ट जमिनीवर काही पार्ट असा उचलला, तर इट इज a curve which does not necessarily reside in one plane. So it need not be coplanar. Is it right? Now, what is surface? As he said, surface is collection of now when we talk of a continuous line, continuous curve, it must be neighboring points. So surface is collection of uncountable infinite connected points to each other, neighboring points, in such a manner that, how will you complete a sentence? बघा म्हणजे आता how the ability of human intellect means it can point which is dimensionless. We can talk about and visualize something with dimensions. So how will you define surface? Collection of infinite points in such a manner that and so length and width you are coming close, but you can directly define. What next? What? It constitutes a non-infinitesimal, means either finite or infinite area. लक्षात रखा. What is a surface? It constitutes either finite collection of points in such a manner it constitutes either finite or infinite area. But means when we talk of a line, we said that it constitutes length but doesn't constitute area. So like that, surface is collection of points such that it constitutes area but doesn't constitute. Now this is something which at least few of you should be able to anticipate my next word. Doesn't constitute volume. Is it clear? That collection of infinite points in such a manner that it constitutes area but doesn't constitute a volume. Right? The area constituted may be finite or may be infinite. And now what about volume? In such a manner that it constitutes a finite volume. Or infinite volume will you say? For infinite volume, now let us see. Line, listen very carefully. Line, collection of uncountable infinite points in such a manner that it constitutes a either finite or infinite length but no area. Surface, it is collection of such points that uncountable infinite points such that it constitutes a finite or infinite area but no volume, doesn't constitute volume. Now what is a volume? Volume is collection of uncountable infinite points in such a manner that it constitutes a finite volume. I am very much particular. मी आता बघा म्हणजे प्रश्न काय करून घ्या. मगाशी मी काय म्हणालो, line is collection of infinite points in such a manner that it constitutes a finite or infinite length. एरियाच्या बाबतीत पण मी finite infinite length but no area. एरियाच्या बाबतीत मी काय म्हणालो, finite or infinite area but no volume. आता व्हॉल्यूमच्या बाबतीत काय, त्याच्या पुढे नो काहीच नाही आहे. युक्लिडियन स्पेसचे 3 डायमेन्शन्स आहेत. पण मी म्हणताना काय म्हणतोय, इट इज कलेक्शन ऑफ सच पॉइंट्स दॅट इट कॉन्स्टिट्यूट्स ए फायनाइट व्हॉल्यूम. मी असं का म्हणतोय, when I am defining finite volume, it is collection of such points. त्यातला such हा शब्द फार महत्वाचा आहे. पहिल्या लाईनच्या वेळेला such points that it constitutes finite or infinite area. such आणि finite infinite दोन्ही होतं. एरियाला पण सच आहे, लाईनला सच आणि फायनाइट इन्फायनाइट लेंथ दोन्ही होतं. एरियाला पण सच पॉइंट्स फायनाइट इन्फायनाइट एरिया दोन्ही होतं. पण व्हॉल्यूमने मी काय म्हणतोय, इट इज कलेक्शन ऑफ सच पॉइंट्स दॅट इट कॉन्स्टिट्यूट्स फायनाइट व्हॉल्यूम. मग सच असताना मी इन्फायनाइट का म्हणत नाही? You got a question first. Line is collection of such points which constitutes length which is finite or infinite but doesn't constitute area. Surface, collection of points, collection of such points that it constitutes finite or infinite area but no volume. And volume, it is a collection of such points which constitutes finite volume. Infinite का म्हणत नाही मी. काही इन्फायनाइट चालेल, त्यात 2 प्रकार येतात. When I say volume, if I am talking of straight line, then only one dimension, infinite length. If I am talking of area, surface, स्ट्रेट लाईन, आता आपण कर्व दुसरं बाजूला ठेवू. स्ट्रेट लाईन असेल इन्फायनाइट लेंथ झाली. एरिया असेल, सरफेस असेल, सरफेस, तर त्याला काय आलं, तो रेक्टँग्युलर असेल, रेक्टँग्युलर असायची गरज नाही. रेक्टँग्युलर असेल तर दोन्ही फायनाइट किंवा एक फायनाइट दुसरं इन्फायनाइट किंवा दोन्ही इन्फायनाइट. फायनाइट कन्व्हेन्शनल लेंथ विथ एरिया झाला. ए स्ट्रिप चा एरिया पण इन्फायनाईट आहे. एक साइड फायनाईट, एक साइड इनफायनाईट. एंटायर एक्स वाय प्लेन चा एरिया पण इन्फायनाईटच आहे. तसं व्हॉल्यूम बाबतीत काय होतं, सम सॉलिड इफ all are infinite, then it covers it is collection of all points, entire Euclidean space. But you still can also have some such points which constitute either finite volume or infinite volume. म्हणजे a cylinder, त्या सिलेंडरचा बेस एरिया फायनाईट आहे, लेंथ इनफायनाईट. सो इट इज इट क्लिअर? So these are the things. What I mean is, we should try to analyze when we have ample time. It seems that you are quite free, at least in these days. So when you have ample time, you should be able to think on these things, especially the very conventional things, line, surface, volume. हे आपण वापरतो, परंतु ते नेमकं काय? So all this discussion started with the concept of surface. Surface वरून हे सुरू झालं सगळं. So when it started with surface, now whether the next question, electric field is a vector, right? Electric flux is a vector. Now we are having a term electric flux over a surface. Now my question is, whether surface is scalar or vector? Whether surface is scalar or vector? Is the idea clear? Surface is scalar or vector? Surface. Now in surface there are many again another things. A curved surface, so we keep it aside. At least we say a planar surface. Curved नको आता. So what it is? Scalar or vector? Hello, हाँ. तो काय सर्च करायला का तो? हाँ. What is surface? Scalar or vector? Vector. So we are talking about, let us say that this surface, very simple. We consider not curve, a plane surface. So what is the direction of this? What is the direction of the surface? What is the direction of the surface? Outwards. So I think you have either read the discussion of Gauss law completely, then how can you say outward? What we mean by outward? What? आता कसं होतं बरेचदा की if you conduct an experiment of litmus test on sulfuric acid, then if you bring non-diluted sulfuric acid, what is the normality of that non-diluted sulfuric acid? Maximum normality, जी विकत मिळतं sulfuric acid म्हणून 36 normality. And if you put a litmus paper, it doesn't become red. So the litmus test fails for highly concentrated sulfuric acid. तसंच झालं. So being is so, त्याला काही आता ते आयन, आता मी विसरलो होतं कारण काहीतरी आयन्स असं काहीतरी लागतं, त्याला पाण्याचं हे लागतं, तर खूपच हे झालं की मग साध्या साध्या गोष्टी कळत नाही त्याचं. सो व्हॉट आय सेड, मी असं सांगितलं की हा फोनची मागची बाजू, बॅक साइड ऑफ दिस फोन, साइड मधले फक्त एवढे, हा सरफेस आहे, हा वेक्टर झालं. मग आउटवर्ड, आउटवर्ड, when the word out is defined, outward, for that, out, for defining out, we must be having some kind of something in. So what he did, outward is a term which is now, so anyway he used the word, so let us, we have to add something to it. So outward is a term which is applicable to which surface? we are talking about whether surface is a vector or scalar. Now, everybody agreed somehow that anyway, if you are in third year electronics, so agreeing that surface is a vector is not a new thing, it's an obvious thing. Now, what is outward? Which surface is having the concept of outward? Is my question clear? When I talk about the word outward for a surface, it means which surface? कुठला? Curve. Outward. आता मी समजा इथला ऍबसेंट मुलगा आता मी बाहेर जातो असं म्हणू शकेल का? Can absent students say that now I am moving out? Why? Because you got hint. So the word outward, direction of a surface is a vector. We say word outward. That concept of outward direction is applicable for which surface? Huh? Which surface? What is Gauss law definition? No? What is Gauss law definition? Gauss law definition काय? Electric flux is enclosed by a surface. मग आता त्यातनं हिंट मिळालं का तुम्हाला? So the word outward is applicable for a closed surface. Because when there is a closed surface segregates the entire volume in Euclidean space into two subsets: volume inside the surface and volume outside the surface. So their outward is defined. But otherwise also, then somebody will say that what is direction of the, he said that what is direction of the surface? Outwards. Then if I only consider this board is a surface, that's all. This white board what you see is a surface. It's not a closed surface. It's not a closed surface. It doesn't enclose anything. Then is it a scalar then? What is direction of a surface then? If it is not closed surface, direction is, so direction of a surface is perpendicular to surface. It's normal, area normal, right? But this surface, म्हणजे डिरेक्शन कुठली म्हणायची? ही का ही? This, only this part, its normal is this. So this is the direction or this is the direction? Quickly. A non-closed surface, there are two possibilities. And there is, we cannot define a rule there. Normal, every area has got two normals in mutually opposite directions. So there cannot be any convention which can be defined. असं डिफाइन करता येत नाही आणि त्याचा फार गरजही कुठे फारशी पडत नाही. What can be done? आता त्याच्यामध्ये समजा in solar, when you orient the plane in the direction of normal direction of sunlight, you get maximum absorption. So in that case, it means when we are having some vector quantity over a surface, normally dot product is used. Normally dot product is used. And when we use a dot product, A dot B and A dot minus B, are they same or different? A dot B and A dot minus B. How?
The magnitude of both B and minus B is equal.
Angle, how you calculate the angle? No, but angle of. So, how you calculate angle? A, it is commutative. Dot product is commutative. A dot B is B dot A. So, how you measure the angle? अच्छा लगा? A dot B being B dot A. When you measure the angle, you will either measure angle theta or 2 pi minus theta or 2 pi minus theta. If you take reverse, it would be pi minus theta. Cos of pi minus theta, is it equal to cos theta? Yes or no? You can think over it. We move further now. As regards to, so a surface means if I am having a planar surface, then you will have same direction at all points, either this or this. If you have a curved surface, when you have a curved surface, a curved surface, direction of that surface is different at different points. अच्छा लगा? Direction of curved surface is different at different points. Now if we consider closed surface, a cylinder, a closed cylinder, मग त्याची direction कशी येईल? So the curved surface, now it is closed, so outwards. So cylinder असा closed आहे, curved surface वर radially outwards येईल तशी. आणि दोन जे स्ट्रेट सरफेस आहेत अशी एक येईल आणि खाली अशी येईल. इफ इज स्फिअर इट्स रेडियली आउटवर्ड्स एट ऑल पॉइंट्स. इज इट राईट? नाव व्हेन वी टॉक ऑफ फ्लक्स ओव्हर अ सरफेस, म्हणजे आता अगदी सोपं असं होतं, सनलाईट आणि एरिया, सनलाईट आणि एरिया. तर मी असा ठेवला, पूर्ण सनलाईट येतो याच्यावर. मी असा केला, एरिया तेवढाच आहे, पण इफेक्टिव्हली काय होतं, म्हणजे सूर्यप्रकाशात मी असा एक पत्रा ठेवला, सूर्यप्रकाशात असा ठेवला, तो वेगाने गरम होतो, तो असा ठेवला. तो एक अगदी सोपा प्रयोग करून बघा तुम्ही. एक पत्रा घ्यायचा आणि तो असा ठेवायचा सनलाईटला, एकदा परपेंडिक्युलर एकदा पॅरलल. तो पॅरलल ठेवतो तो गरम होत नाही, पॅरलल तो गरम होत नाही, परपेंडिक्युलर तो मॅक्सिमम गरम होतो. किंवा तुमचं सोलर पॅनल ऍक्च्युली मॅक्सिमाइज काय करतात, सोलर पॅनल सुद्धा काय करतात, काही एवढी गरज पडत नाही आपल्याला, पण ते परपेंडिक्युलर असं रोटेट पण करतात मॅक्सिमाइज करण्याकरता. अदरवाईज त्याची गरज नसेल तर प्रश्न नाही, पण असं ठेवलं तर हे म्हणा. त्यामुळं दी कॉन्सेप्ट ऑफ the electric flux over a surface, electric flux over a surface जो concept येतो, so in that case it is the dot product of the flux. It means electric is vector, so vector, not only flux, any vector field over a surface means that vector field, its dot product with the surface vector or area vector. आणि जेव्हा आपण ओव्हर म्हणतो तेव्हा डिरेक्शन कुठली कन्फ्युजन आहे, म्हणून नॉर्मली ते क्लोज सरफेस असतं, तेव्हा डिरेक्शन आउटवर्ड्स. सो इफ we are having a closed surface, then at every point on the surface, if we calculate the dot product of the surface vector and flux vector and sum that over an entire surface is equal to charge enclosed. मग आता याचं सोपं प्रूफ कसं करता येईल? अगदी सोपं. If a point charge Q is at the center of a sphere of radius r, the capital gauge r, general like given. If I have a charge at origin and a sphere of radius r, तर त्या sphere is symmetrical around origin, प्रत्येक point distance r आहे. So electric flux density D at every point on the sphere is Q upon 4 pi r square. बरोबर? Electric flux density D at every point on the sphere is Q upon 4 pi r square. What is the direction? Radial outwards. What is the direction? Now if we talk of electric flux density over the sphere, तर over the sphere means पूर्ण एरिया काढायचे. स्फिअरचा एरिया S म्हणला तर मी एक स्मॉल हे घेतला सरफेस, त्याचा एरियाचा ds घेतला. ds, what is ds? ds is a small surface. स्फिअर वरचा पॉइंट घेतला आणि त्यात थोडंसं जवळ घेतलं ds. तर what is the direction of ds? Outwards, radially outwards. What is the direction of flux? Radially outwards. So both are in same direction. So what would be flux over that surface, small infinitesimal surface ds? Dot product. It is d bar dot ds. What is that? Since both are in same direction, it would be Q upon 4 pi r square into ds. Right? And what would be over entire surface, spherical surface? Its volume integration. Its surface integration over a closed surface. What is that? It is constant everywhere. So it will be Q upon 4 pi r square. And what is the integration of ds over spherical surface? What is area of the sphere? 4 pi r square. So Q upon 4 pi r square into 4 pi r square. So Q. So if it is at the origin and the spherical surface, it is simple. Now for today's tutorial, take the problem. It is at origin. A charge Q is at origin and a cube is of 1 meter side. म्हणजे half on this side, half on this side. 1 meter side चा 1 नको 2 चा घ्या, म्हणजे सोपा होतो. A cube of each side 2 meters is situated such that its center is at origin and a charge plus Q is there at the origin. Prove Gauss law for this cube. We continue at our regular lecture. Thank you. Attendance.